Hello, and welcome back to Tips and Tricks. So I did another oopsie, and for some reason OBS did not record the audio for this video. So I am doing a commentary like I did for a few other videos so far. So still working out the quirks on recording. But what we'll be talking about in this video is some of the other cool tricks that you can do with interfaces. So interfaces are very cool because you don't need to implement everything before you use them. And so you can really leave this you can leave a lot of work for someone else to come back and implement later. And so we're just kind of going to go through an example of how we might just go ahead and establish a few interfaces, establish a few quote unquote contracts for someone else to come back and code. I mean, and maybe that someone else might be us, but we're just going to go ahead and use an example. So the example we're going to use here is just to say we're building a fake Twitter. Again, or we're building a real Twitter. We're going to conquer the world with our new version of Twitter. And so the class that we have here is a profile displayer class. And this class might just be responsible for laying out how your profile might look. So if you can think about a LinkedIn or a Twitter or Facebook, maybe you hover over someone's image and a little modal pops out and it has a bigger version of their image, and then it has maybe their name, and then it has their maybe some titles next to it, and maybe has their age. So this would just kind of be the pop out display of this user's profile. So to kind of help us along the way, we can build a struct to store all the data that we're going to use for this little profile modal. And like I've always said before, structs are they're the best at storing data to me personally, because we can very explicitly say that this is just storing data for this. And so we're building a struct that's for the user profile right here. And now we're just kind of thinking about what are the attributes that we might want for this little modal that's a little pop out here. And structs are very good with interfaces. I think they go hand in hand really nicely because you can go ahead and define, and with an interface, you're not necessarily defining any of your functions. So it can be kind of difficult to understand just from the functions, like how data is supposed to flow through the system. So it could be really handy to also hand someone a bunch of structs and tell them, well, you'll be passing this struct between all the databases, or this is the struct that I'm trying to build. So this can kind of help inform people. So here we are building out some of the attributes in our struct. So we have a byte array of images. And so for people that are unfamiliar, an image file like a JPEG or a PNG, that's going to come to us in an array of bytes, or it could be coming to us as a stream. Most streams allow you to dump into an array of bytes. So we'll store the actual image in a byte array. Then we'll have the username, we'll store that as a string, and then we have the age, we'll store that as an unsigned int because age can only be positive, and then we'll have a string for the title. So, the title maybe is just something like, oh, this person is a software dev, or this person works at a large corporate company, and all that stuff. So something that the user might want to display about themselves for their title. Oh, okay. And so here I am. I'm just kind of talking about, the modal that you would have for displaying all that information. So this profile displayer, we're going to give it as I've stated before, class should have a very explicit purpose. And it should be a very clear tool for doing something. And so for this profile displayer class, we're going to give it the purpose of building this user profile. Now, as we go along the journey of creating this user profile, keep in mind that our job is nothing else. Our job isn't to create encryptors or create databases or anything like that. Our job is to create the user profile. And then we will call other things that might create that user profile for us. So this get user profile, that's the method that we're going to define. It's a public method so other people can call us and get this user profile. And we're kind of instinctually giving it a parameter of user ID. This is a very common practice to use a unique ID. These are called either PUIDs, like personal identification, or personal unique identification, or You might see UID, just unique identification. And then, yeah, so in this case, this is UID, so a user ID that will just map to a lot of this information. We're just going to assume that, and this is what we're doing when we're making a contract. We're just saying, hey, I want to be able to get all this information with just a user ID. So we're telling, if you're working on a team with somebody, that's what you would be telling them, is that I want to be able to get all this information from just a user ID. And then you're going to form your databases accordingly to allow this thing to access with just a user ID. Now, this is not a contract written in blood. Like, you can go back and change this parameter list to be whatever you want. You might find out later that, well, I actually need your session ID as well. And that might be fine to add that in as a parameter here too. Just to note, you might have seen that we added public to all those attributes in the struct. That's just so that we make it accessible. Okay, and here we go. We're building the first interface that we're relying on. So here in the constructor, we're saying, and I've put I in front of it because we always put I in front of our interfaces. That tends to be the pattern. And so what I've told, as I'm building out this contract, I'm saying that, hey, I have this profile displayer class, and this profile displayer is going to rely on some other tool called photo retriever. In some way, I'm going to rely on that thing. And so I'm relying on someone else to go build that for me. And then the code that we're doing here is just very basic, just storing a reference to this passed in photo retriever within the class itself so that our methods can come back and use it a little bit later. So you can think about this as just kind of caching. We're just caching everything that's coming into the constructor so that we can use it a little bit later. And so, here we are just kind of doing the basics setup on here. And you can note that I haven't made any class. Like, that's what the red squigglies mean, is that, hey, you haven't defined a class called iPhotoRetriever. You haven't defined an interface called iPhotoRetriever. And so we're going to go implement all that stuff later. But in the meantime, we're just saying that, hey, ideally I would have something else be responsible for retrieving photos and images for me. So I'm in the business of making the user profile. I don't want to go off to a database or go to a CDN and ask it, hey, I want this image. Can I associate this image with a user ID? I might not be able to. Like, that call to the CDN might involve HTTPS requests, that it might require tokens, unique tokens, auth tokens, session IDs, formatting my request into a JSON. It can be a really involved process that I don't want to get into. All of a sudden, this, a couple of lines of code that I have here turns into hundreds of lines of code. I don't want to get into that here. I'm just going to rely on someone else to code that for me in the future. And when I say someone else, that could be us a day later, or it could be us in a couple of minutes. But I'm just saying that I don't want to get into that work here because a class just has a very specific purpose. So here we are, and here we say that for our image, we want to use this API. So here we're even being a little more strict with our contract, and we're saying, well, for photo retriever, not only do I expect someone else to give me some photo retriever class, here's the endpoint that I would like them to define for me. So I would like them to define a retrieve user photo endpoint, and I want that endpoint to take a user ID, that's an int, and then I want it to return out to me a byte array. So I've said that these are the things that I'm demanding. And you can be very demanding when you're the first person designing something, because you can just say, well, this is the code. This is how I would like the code to act. And so sometimes you can't make code this quote unquote pretty because you're relying on other people's APIs. Or if you wanted to make code this pretty, you might have to kind of do what's called proxying and adapting, where you might have to go to find this method that's a wrapper on some other method that's doing all this stuff for you. So, but that's a whole nother topic. Okay, so here we're saying, okay, cool. I will get my image this way, but I'm not gonna worry about that right now, because and as you see, the red squigglies don't appear right here because it's like, okay, we're assuming that this function will be defined for us, and everything should be fine. I'm okay with it. Really, the compiler just hasn't gotten to processing this error yet, but And so now we have to kind of think about the same thing for username, age, and title. So one of the things about that is that those feel like user specific attributes. So we might be able to, we might be able to make some assumptions here that maybe there's one object that's going to be responsible for all those attributes. So that object might not have been responsible for storing the image of the user. That might be a completely different process, because for sure, grabbing images, that requires talking to CDNs and all this stuff. But grabbing the username and the age and the title, that might all be located in a single table somewhere else. That's completely apart and disparate from the images table, because the images table, you could imagine it's just, maybe it's a table that just has user IDs and photo URLs, and you go to it with a user ID, it gives you a photo URL, and you resolve that photo URL and it gives you just a byte array out of it. So, and then whereas there's another table over here called maybe user info, maybe it's called user profile info, and then that user profile info has username, age, title, password, all this other kind of stuff inside of it. But it doesn't necessarily have links to the image. And people do this all the time, because it's all about kind of making the most efficient database that you can. Because especially if you're making a lot of calls to this database, and if you're making a lot of calls to this database to get images, so say that you were actually storing the images inside of your own database, well, you don't necessarily want to make calls against a database like that to get very common information when you're never getting the photo, but you're not getting the photo very often. So imagine that you're getting the photo 1 out of 10 times, and you're getting username, age, and title 9 out of 10 times. So you would want those to be in separate tables, because that could cost you a lot of money making calls to tables whose attributes you're never using. So here we are. We're relying on, now we've made another contract, quote unquote, where we're saying that there's this user info retriever object is going to, or this class is going to be responsible for giving me some of these some of this data out of it. And let me be very specific too. Just because we've called it IUserInfoRetriever, that doesn't mean that we have to actually name a class UserInfoRetriever. So like I say, we put I in front of interfaces, and then if we remove the I, you might think that that's the name of a class, but anything can implement the interface that we're about to define. So you could have something like, I don't know, just like random data retriever that implements the endpoints of IUserInfoRetriever and just gives you functions like this that you can use. So here we are. We're saying that for the username, we're going to call it like UserInfoRetriever dot get display user name. Now you might ask, why am I saying something like display? And there's different philosophies on using display in the name of your function, but here we're thinking about building a UI for something. So the username that might be in the database might be misformatted. Maybe you need to capitalize like the first letters of things and add hyphens and adjust it in some ways to make it conform to your app. So getting display username, that kind of is an inference to someone that, hey, I want you to format this in the right way. Another way that it kind of cues someone in that's developing it is it tells them, hey, maybe I need to take into consideration other things, like what's the context of this username? So what language or what region am I displaying this username in? So if I'm in China, maybe I want to display this username in Mandarin or whatever the language preference that the user has specified. Whereas if I'm in the US, maybe I want to display this thing in English. So that's what kind of a get display might be versus just get the username, which might mean just give me the raw data that's in that table. So we're doing the exact same thing for all of them. And you can imagine that there's all kinds of other contexts. And this is the good thing about you letting other things do all these calls for us. Like if this get user profile was responsible for adjusting the username to make sure that it's pretty, making sure that the image file was formatted correctly and had things in the right space sizing, made sure the age was a valid range, and then made sure the title was, if it had all these responsibilities, this would be a really hard piece of code to maintain. And then you could imagine other pieces of code feeling like they have to duplicate that logic to make sure that stuff printed out all nicely. But because we're putting the responsibility on other classes, now you have a uniformity throughout your app. So all these other classes can call a user info retriever to get the display age, and that's going to be the default method that most people will call to get the age. So few people are going to go and say, well, I want to get the age by querying the database myself. If they see that a client is already doing this work for them, they're going to latch onto that work. Whereas if they just saw get user profile was querying the database and getting the age and formatting it, well, they might just be tempted to duplicate that logic instead of doing the work to refactor and pull that kind of code out into its own class, and then adjust unit tests, make unit tests for that class, and do all this other work. So you kind of want to be good and give people. You want to make life easy for people that come after you, and just separate out responsibilities into different classes as much as possible. So here we just used the IDE to go ahead and make the interfaces for us. And so here we have just 2 empty interfaces, and we resolved the compiler errors for our constructor. So we're good. Now we have new compiler errors that are saying, well, you haven't defined these functions in those interfaces. So I don't know where these things coming from, where are they going to get defined? So my code's not going to work unless you give me the guarantee, you give me a contract that says these endpoints are going to be there and they're going to return this type of data. So, now the work might be, well, I have to go implement these, right? No. In fact, all you can have to do is just go to the interface, type in the name of the functions, give it the right return types, and give it the same list of parameters, and you're good to go. Now, one thing to keep in mind here is that you will have to make sure these methods are public or at least internal to qualify as contracts for the interface. So when you're implementing this, so as a basic class, and I'm not going to show that here, but when you're implementing it, I'll show that in like another tutorial, but you'll have to just make sure that you implement this retrieve user. Oh, I've actually already implemented it in the previous video on this. So you can see that that's how we implemented this function, but now we can see the error goes away because it's happy, because it's saying, okay, you've given me the guarantee that whatever comes in here will implement this method for me, because you've given me the guarantee that there will be a photo retriever or a thing that implements the interface called iPhotoRetriever that has this function tied to it. So it's just that these are all kind of contracts that are just saying, yes, something will implement these. And if something comes in here saying that it's an iPhoto retriever, then it will implement it for you. And so you can go ahead, compiler. And so the same thing goes for the user info retriever. Now, one thing we noted here is we're using user ID to get the user photo. So once again, this makes a strong assumption, and this is not, this isn't always the best way to code out your databases, because you maybe already have an idea of what your database looks like, and so you want maybe your functions to reflect that. But here, there's just a strong preference on making the coder's life easy versus the database engineer's life easy. So here I'm just saying, hey, I just want to be able to use a user ID to get this information. So database engineer, code it up, make it like this. And once again, that's the perk that you get if you're the first person to code something. So here, kind of the same thing. So we have to think about, what is someone going to need to get the username, the age, and the title in the future. So right now I've left these empty, but that might not be very realistic. So, or you could think about, for those functions to resolve, what would be the data that they would need? So likely they would have needed the context of the request. And so where are you going to store that context? You can have, and I've seen certainly implementations like Flask, it'll store a global context of a request that you're carrying through the program. But that's a singleton model, pretty complex thing to implement in parallel. So you maybe don't want to go with that. Maybe you want to make your function just a little bit more generic and something that is near static. And that's what we're really going for sometimes as we're coding these things. So the reason these things become classes is because they're storing references, but you can almost turn these things into static classes and just pass all the references into each of the methods, but that just makes them really kind of hard to use. And definitely one of the other things you're thinking about here is that these classes might have a really long lifespan. So we might make all of these classes, like we might make photo retriever at the beginning, and we might make user info retriever at the beginning of our server. Once it starts up, it just has these classes available, and then all our requests are just going to keep calling into these methods. So so right now we're making that kind of an assumption, and so sometimes you might not be okay with that. If these classes were really heavy, you might want to actually generate them on demand or lazily generate them. So you'll have to kind of consider that for your use cases. But in our use case, we're saying that these are pretty lightweight classes. We're going to make a lot of lightweight classes at the very beginning of the program and just keep them alive. And that's usually going to work most of the times. So it's very rare. And like I say, if you have classes that are very chunky, take up a lot of space, that's when you might think about, okay, maybe my implementations need to instantiate things on the fly. So it's kind of up to you. So here we are. Once again, we're at the interface. We're building out this contract, and we've said, okay, it's going to have these 3 endpoints at least for something to use. And then, yeah, here we've made the decision that, you know what, I want to make this a bit more generic and standard. So if I had not given a parameter, like I say, it would have had to pull something globally from somewhere. And so that makes my life maybe a little bit too hard. And maybe it's not something I want to depend on for this design, but it's totally fine if I go to that design in the future and just say, I'm going to carry some global context that I promised to always have to get this stuff. But here, instead, I'm just like, no, it's just a static method. This is easy to unit test. It's just like, yeah, okay, just give me a user ID and I'll get you their display age. And just logically, and this is logic that you build up over time building programs, you're like, okay, yeah, I probably can make a table that's very easy to get this information just from the user ID. You would think so. If you have a unique user ID, I would think that you could associate a username to that ID and get an age and all of that. Now, maybe title might be stored in a different database, and maybe user ID wouldn't be the key for that for some reason. And so maybe that could be a more complex join, but you could think that user ID is going to get you to an important table that will get you to the title. So here we are, we're coded, we built it just fine. And I think that that's the magic of interfaces. We haven't really done any hardcore coding right now, but we've already got our build working just fine. We've built contracts and we've already established the names of all the methods and what they're going to return to us and what they're going to take. So we've already done a lot of the design work here. And that's what I say is what's really cool about interfaces is you can kind of build a skeleton of your program very early on and then come back later and flesh out that skeleton with the meat and the flesh of the program. So, and that stuff might take a lot longer and might require more extensive data reviews, design reviews, because for sure, the photo retriever might require a very extensive conversation of what CDN are we going to use and what database are we going to use and how should the tables be laid out. That's a very complex conversation to be had. But with this code, you can just say, okay, well, I'm gonna hold off on making any of those decisions right now. I'm just gonna assume I'm gonna make this contract that just says, hey, I'd like these things to be given to me like this, and that's a very easy design discussion to have, because most people are gonna say, yeah, using the user ID to get that stuff makes a lot of sense, and it's very easy to come back to that later. And so here we're just kind of building out a unit test as usual. And I just wanted to kind of show you. So here you can see the compiler is saying, hey, you can't, you're trying to make a constructor, but you can't instantiate an interface. So this might make you ask, well, how do I test my code? Like I built out all this code. Like there's, I need to at least be able to build my unit test for it and at least see that it's working. Like right now it feels like magic and, I don't trust it. right? And it's like that's a valid question. And so, and this kind of gets into a discussion, and I'm gonna kind of fly through it. I know in this code, but this gets into a discussion of, well, what if I'm just kind of coding out? So, I'm working with my UI dev, and I'm coding out all this stuff. Where am I gonna put in the default values that I can just use during testing? Now, most people, where we did those function calls, what they would do is they would just hard code the defaults right there, and then it would be very hard and arduous to remember where did I code all these defaults, and I didn't remember to write a little to do to replace this thing, and so and then you're checking that code into your code base, and so that's pretty awful, honestly, to code it out. So what's better to do is to use what are called mocks, and we'll discuss mocks in a future video. So I'm not going to go fully into them, but we can use mocks here to give us a mock MOCK request, or give us a mock response for what a real object might behave like. So I think I'm going to write out, okay, yeah, so I'm writing out just here's some of the default values that I maybe would expect for, to use just when I'm testing out stuff. And so, like I said, in the past, I can remember definitely in my college days and early dev days, I would just hard code all that stuff there and just keep moving on. It's like, oh, I'll figure this out later. Right, something else is going to fill that in. But now we're being a little more elite and just saying, well, I'm going to have a really good function fill this out for me genuinely. But what I can do here is I can actually go implement this mock class to define these endpoints for me. And it's actually really quick, right? Boom. So I put this photo retriever, and I give the promise that this class will implement all these members explicitly. And here you always get this default throw not implemented exception, which can be very handy to just kind of get your code moving once again and be a reminder, hey, you need to go implement this later. But here we're just saying, nope, I'm going to go ahead and return the default. And just like that. So you could imagine giving this a default link to an image, or like a default byte array of an image. And I'm going to do the exact same thing for that user info retriever. And this is just one way of making mocks. I actually would advise against doing this unless you're deploying this code out to prod or your PPE environment, and you want your tester to be able to use this code or to be able to test to make their UI. Then it's like, okay, you're going to need a physical class. And these are fairly easy. It's just that they can get expensive. You can imagine that if this user info retriever had 100 methods to it, it would be pretty expensive to code up a whole class that had 100 just kind of fake methods on it, and then they're all going to get erased in the future. But honestly, it's one way of going about it, and you can kind of keep this class forever. But there are things called substitutes in the mock MOQ class that allow you to do this default value sending without having to actually make physical classes, and those are pretty handy to use. It's just, yeah, I would have some suspicion about using them in my build process, but that it can work. I would have some suspicion about sending that out to prod, but whereas yeah, if I have physical classes like this, I might be more okay. But yeah, I guess they're kind of the same though. They're kind of the same. So here we are. We instantiated our mock objects, and we sent them into the constructor. The constructor is happy, and now we just want to call get the user profile. We're going to give it just some random user ID because our mocks didn't even consider the parameters in their implementations. And so now if we run this, we should, and we're just going to use the debugger for this, and those tutorials are going to come soon on how to use a debugger, but we're just going to run this. And then we should see that, boom, there's our default value. So that's exactly how we expect it to be. This is this has this. So now our UI dev, they can go figure out the UI, make sure those things, that modal pops out properly. But yeah, we are pretty much done. And the work now would be to progressively get rid of these mocks and to replace the mock photo retriever with a real photo retriever, and then replace the mock user info with a real user info retriever. But just like that, you've done a lot of the work. Now you haven't done, it can, one of the dangers of this is that it can feel like you've completed the deliverable, and you really haven't, of course, but you've done about, what I would say, about 20% of the work. And that 20% of the work is the skeleton of your program. And so now you get to actually focus on the much harder, or the much more involved issues. They might not necessarily be harder because design is hard, but now you have to, the photo retrieving is a very involved process, right? Like I say, it has a lot of moving components, and you might have to build a lot of interfaces and clients to get that to work. Like I could imagine for the photo retriever that you're building a client to interact with your CDN, a client to interact with your database, and then maybe a client to just send generic HTTPS request off. So that, there it is. Those are 3 clients that would all need interfaces, and it goes on and on. Maybe maybe as you're building each of those clients, you might need to interface more stuff and build things deeper within, so that you just are building all these reusable tools that other people can latch onto. So that's just one thing to kind of consider. Is you're just slowly cracking away at the problem. And while a lot of this stuff can just feel like overhead, it's like, I just wish I could have just written a SQL query to grab the image out of a database. What this does is it encourages you to actually code the problem in a proper way, because you can feel like you've already done the profile info. This is very extensible. It's very easy to make changes to it in the future. And it's going to adapt to any changes that you make really well. So you can have multiple implementations of a photo retriever and a user info retriever, and they're all going to fit in here and play with each other really nicely. So, but yeah, one of the things I think we are done on here. One of the things I want to discuss in the future is abstract classes and how they might kind of work in situations very similar to this. And so I believe that's going to be another voiceover video. But yeah, I look forward to talking about that. Once again, I just wanted to state that I just love interfaces, and I love designing my projects just like this. Like it's really nice, and it can just make a very complex project become much more simple to wrap your head around. And very nice, I think, even in hackathons and places where you're moving really quickly and prototyping, because you can give each problem off to somebody else. Someone else can go implement. Now, if you publish this code to your repo, someone else can go work on photo retriever, and someone else can go work on the user info retriever, and then they can submit that code separately. And then in the future, you come back later and just join everything together, and you're good to go. Or yeah, each person can progressively get rid of the mock call and just pop in the new, whatever their implementation is. So I think it can be super handy to code this way, and you instantly start to parallelize the work that can be done on your project. And it's certainly a tool that you should be leveraging. I mean, you can imagine in the past, if you weren't using interfaces, then you would immediately have to already have your implementation for image, username, age, and title already figured out to implement it right now. And even if you the fact that you're using an interface instead of the name of a class, if you use that, it would be throwing a lot of exceptions, and you would be introducing just bugs into your code. Whereas you now are using interfaces, and because you're using an interface, you don't have to do the work of implementing anything just yet. So you aren't introducing bugs to your code. Whereas if you have a lot of throw new exceptions, you might not catch that. And next thing you know, your app is throwing 500s that are not being caught, because it can be very hard to remember to go through your code and look for all the throw new, not implemented exceptions. So I'm a big fan of interfaces, and you should certainly be using them. And it should get to the point to where interfaces and structs are just secondhand for you, because it's just you defining a contract. So if you were working on a project with somebody, and you were trying to write out the terms for the project and talk about all the stuff that you're going to do in that project, you would write out just a schema of all the work that's going to be required to do in that project. And so that's what interfaces allows you to do just in the code world. And yeah, you can see that unit tests work very nicely with it, and even the concept of mocking things works very nicely with the idea of a UI dev working next to you. So you can imagine, even with a UI dev, they would be more easily and more willing to come into a mock class and change the entries in that, much more than they're willing to go into any of your core code and change that. So you've separated out now your UI and from your controllers and even your models. So because your model is right here sitting in a struct, and that's not going to change. You haven't coded any default values into it, so it's bug free. Your controller, it's not going to change. You haven't coded any bugs into it, so it's bug free. And it's just literally your mocks are sitting here as code that you just have to click delete on and replace it with the real thing, and you're good to go. So okay, so that is all for today. Hope to see you back for the next one. Like I say, that will be on abstract classes and just some of the differences and why you might want to use an abstract class over an interface in the future. So I'll see you over there. Bye.